All right. Well, good morning, good afternoon, depending upon where you're located. Here in Eastern Time Zone, we are approaching noon, and so we'll go ahead and get kicked off. On behalf of Fort Wayne Metals, just want to thank you for carving out some time in your day to spend some time with us this afternoon. This is actually the third in a series of about six webinars. Perhaps you caught either the first couple, the first one, our core business segment provided an overview of capabilities in their stainless steel portfolio, covering round, flat shaped SLT wire bar products, with a special focus on some of the high performance materials used in braiding applications. Some of you may have caught our second webinar in the series, which was supported by our nitinol business segment, where they shared kind of their journey to how they've become the world's premier melt to wire partner for nitinol, covering various product forms, again, from bar to fine wire to strip to sheet, and of course, shape set components. So if you did happen to miss either of those two sessions and you would like to be connected to a video to see a recap, please reach out. You can either send us a message in the Q&A, you can or better yet, even reach out to your sales rep, and they'd be happy to send you a link to that video. However, today's webinar, my team and I have the opportunity to share how the third leg of our stool, the assembly business segment, can partner with you beyond simply wiring the spool. So by way of introduction, I am Matt Vanderoost. I'm the Senior Product Manager supporting our assembly segment. I have a team of product managers and business development managers that support everything from our existing products to new developments with our customers. And today, I'm actually filling the role of Tyler Ransom, who is our product manager for our DFT wire and high performance alloys. He is actually out traveling to the Asia region and going to be supporting MedTech China. So I will be covering a few sections in this presentation for him. I am joined by a couple of the product managers on my team, both Brian Woodbury and Connor Bates, and I'll let them take a brief moment to introduce themselves.
Hey everyone, my name is Connor Bates. I'm the product manager for HHS Tube Assemblies. I've been at Fort Wayne Metals for a little over 3 years now, and I've been in the medical device manufacturing industry a little over 5. So I cover the HHS Tube product line, and we'll get into what that looks like here in a little bit.
Hey everybody, my name is Brian Woodbury. I am the product manager for our Strands, cables, and assemblies. Been at Fort Wayne Metals, similar to Connor, just over 3 years. Prior to Fort Wayne Metals, I had a background in industrial automation. So excited about sharing a little bit with you guys about what we have going on and some of the new and exciting things that are going on in assembly.
Perfect. Thank you, guys. Hey, for those of you that really appreciate having a map, or maybe more applicable for today's times, having a GPS or navigation system showing you the route, just want to briefly share an overview here of our agenda and where our conversation is going to be headed. You can see starting off, we're just going to cover just a brief snapshot of the story behind the assembly segment and how we got started in support of our customers. Then I'll be covering a brief section for our DFT wire and high performance alloys. I'll pass the baton over to Brian, where he will share how we can take those materials and further enhance their performance through stranding and cabling. Then Connor's going to step in and cover our HHS tube. Then I'll come back to you and cover some of our coated and ablated products that can add some features and extra performance attributes to our strands, cables, and wires. And finally, Brian's going to wrap up with our custom assemblies and how we put some of those various components together into some working assemblies for your team. So near the end, Connor will be hosting a brief Q&A that will be following the discussion this morning. And simply by way of housekeeping, please note that we'll be using the Q&A functionality in Teams for this webinar. For some of you that may not be familiar with that, there's a Q&A button at the top. What that'll do is that'll bring you into a brief window where you can enter a question directly to our team. It will not be necessarily shared with everybody else on the webinar, So if there's something specific to your team, we won't be answering that at the end with the general assembly here, but we can certainly chatter you back and connect with you as needed as follow-up. If something is a general question, we have a few minutes set aside at the end where we'll be happy to answer any questions, maybe something that we didn't cover in depth. So as we're flipping through the slides, as we're covering the different sections, please feel free to leverage the Q&A section, and Connor will be kind of monitoring that throughout the session, and then at the end, we will circle back to answer any questions that we're able. Also, by way of housekeeping, just let you know that we will turn the cameras off on the presenters. What that'll allow is the content to fill the screen. I know it's difficult at times working from whether it's a laptop or maybe even a mobile device or whatever, where the content can seem kind of small. So we're going to go ahead and turn off the cameras, but don't fear. We're not handing you over to a pre-recorded session. We are still here live, and we will join you again near the end of the session. So with that, I will be starting the session off here with talking about the birth of our assembly business. So just like each of the various facets of our assembly business segment has its own story, I just want to share one example, and it comes from our custom assembly product segment. So you saw on the agenda, we're going to be covering coatings and stranding and HHS and various portions of our business. All those wrap up into custom assembly. And over the years, as Fort Wayne Metals has grown and offered high performance materials to our customers, many conversations have led to the question, hey, can you help us with that next step? And in the early 80s, some of those conversations started to evolve, where customers were asking us, could you help us with taking that next step with strands and cables and wire? And so rather than providing the material on a spool, could we provide cut to length? Could we do some end terminations? Could we fuse the end of strands? And so in the upper left of this slide, you can see a room. It's about 10 by 20. And that was the initial room that kicked off our assembly, our custom assembly product subsegment. You can see in the picture next to it to the right, you got some equipment, a couple operators. There were just a couple folks working in that room. And what their mission was to be able to provide some fusing of the ends of cables, maybe cut to length, but just some of that next step for our customers to aid in their processing. Well, obviously that business has grown over the years, and we continue to partner with our customers, trying to listen to what their needs are. And you can see the facility in the bottom picture there. That is our ABG facility that houses our assembly department. A couple years ago, we went through an expansion, and you can see that we continue to grow and invest, and we're ready to carry in that conversation, supporting your next needs with custom assemblies. So one of the areas that we want to kind of start with here is one of the foundation of where the wire comes from. Core covered the stainless steel product line. The nitinol team did a beautiful job with nitinol. Our assembly team actually supports our DFT wire and high performance alloys. And many folks are very familiar with stainless steel. You know that, hey, yes, it has to have a minimum of 10.5% chromium. In order to qualify as a stainless steel, that's what gives you the oxide layer, leading to improved corrosion resistance. At times, there's blended a little bit of molybdenum or cobalt into the material that may enhance some of the properties. But at the end of the day, when folks are engineering a device or need additional performance out of the material, you'll turn to a high performance alloy. A couple of the standard alloys that we routinely support throughout the industry are shown in this table. You may recognize some of those from our website, but the first couple on there being 35NLT and MP35N. I'm not going to cover in detail here. I actually have a couple slides following that will talk about some of the similarities, how they're set up, and some of the differences. But just please know that they're a multi-phase alloy, meaning that they've got more of a complex grain structure that allows them to really impart both strength and ductility at the same time. They as well as most of the alloys on this list are cobalt based, and they have about 35% nickel, hence the 35N, as well as 20% chromium, so roughly twice the amount of chromium as stainless steel, leading to improved corrosion resistance, and also 10% molybdenum. So right below them is L605. L605 alloy is another cobalt-based alloy. However, it does have about 15% tungsten in it, which leads to extremely improved high temperature performance. It also has 20% chromium, which gives it its corrosion resistance, and it has a little bit lower nickel content. Form Metals 1058, directly below there, is known according to the ASTM 1058, but in the industry, you may recognize some common trade names such as Elgiloy or Finex, but it roughly has about 16% iron in it, and it originally was used in marine applications due to its corrosion resistance in marine applications, watches, those type of things. It does find its way into many different medical applications. Fort Wayne Metal 1537, the last one on this list, is a cobalt, chromium, molybdenum material, so it's a CCM. It is widely used in orthopedic markets, also spinal trauma, and also with dental devices. So as promised, we will press in just a little bit here on MP35N and 35NLT. Again, the MP references multi-phase, 35N references 35% nickel. Both MP35N and 35NLT are very similar in a number of ways. They are both based on the ASTM F562 chemistry, which I mentioned on the previous slide. Both of them have similar melt processing. So they use vacuum induction melt, VIM, followed by a vacuum arc remelt. Both of them, of course, meet the ASTM F562 specification. However, there is some significant differences. So the titanium content in MP35N is up to 1% max, and with 35NLT, it is limited to 0.01%. So 35NLT, or you may think of the LT as low titanium, that significantly limits, so about 1/100th of what the max composition in MP35N. And the next slide will start to press into why that is. So in the 80s, Fort Wayne was working with many medical device companies and trying to improve the performance of our materials. And some of the things that limited the fatigue performance of MP35N, which was an industry-leading material, was the presence of titanium nitrides and titanium inclusions in the actual melt material. And so Fort Wayne worked with our industry partners as well as our supply chain to design a melt that allows us to remove a significant portion of the titanium, and thus it imparts very different properties in the fatigue life. In the picture in the upper left, you can see what a typical titanium inclusion looks like in MP35N. You can see that there's a lot of jagged shapes that lead to stress risers in the material, leading to wire fatigue breaks. The picture right next to it, that circle, is what a typical inclusion looks like in 35NLT. Not only is the inclusion much smaller than what we find in MP35N, but the shape itself significantly reduces the propensity for stress risers within the material. As evidenced in the table below in the chart, you can see the red trace is for MP35N, the blue trace is for 35NLT. And what the table shows along the x-axis is a logarithmic scale of the number of cycles that a material can impart or can survive during a cyclical rotary beam fatigue test. So for those of you that are not familiar with rotary beam testing, you can basically take a wire, you put it in a U shape. One side is chucked and hooked up to a motor that spins the material. The other side of the U is pressed into a bearing and it's allowed to freely rotate. So as the motor turns the chuck at roughly 3,600 RPM, you can envision that wire rotating in that U shape. Each rotation is considered a cycle. And because of that shape and the rotation, it's like flexing the wire back and forth. So what the table shows is at a given stress level, which is on the vertical axis, you can see that the trace for the 35 NLT is to the right, and it is upward or higher than the red trace for 35N. And so what that shows is that at a given stress level, the 35 NLT survives roughly, well, it's multiple orders of magnitude, up to 10x, more cycles than what the MP35 is. Or you can say at a certain fatigue life or a certain number of cycles, the 35 NLT is able to survive a higher stress level than what the MP35N is. What this led to was a significant improvement in the performance of material and coiling for pacing leads, the proliferation of use into neural stimulation leads, and over the years, 35 NLT has replaced many applications for MP35N. So part of what I said we were also going to cover is our DFT wire. Our DFT wire combines the properties of dissimilar materials into a single wire system. So basically you can take the advantages of two different materials or three and leverage those within a single wire. Where this originated from, down at the bottom, you can see that Fort Wayne introduced a material called DBS into the industry in the 60s. And basically, DBS is where we took like 6 wires of stainless steel that were wrapped around a core of silver. That strand was then brazed, which allowed the silver to proliferate amongst the different stainless steel filers in that strand. And that improved the conductivity. So we were taking the fatigue and the mechanical properties of stainless, joining it with the conductivity performance of silver. And that DBS material was drawn to final size and used in many different CRM applications. Well, once MP35N was introduced to the industry in the early 80s, we started to see a significant improvement in the fatigue life. And so we wanted to be able to leverage the fatigue performance of MP35N along with the conductivity of silver for CRM applications. And so Fort Wayne developed a system to be able to take a sheath, an outer sheath of MP35N, and we would fill that with a core with silver, or it could have been platinum for radio opacity. But those 2-part systems or even a 3-part system allows you to take advantage of the properties for each of those materials. This DFT wire can be drawn to similar sizes as other materials, such as it can be drawn to 0007, and we provide all the way up to 0.0126 inches. Various strength levels can be developed by a cold wear profile. And of course, we can offer DFT wire in various forms, such as round, flat, we can do shaped, we can give it different treatments to optimize the performance for your application. To finish the journey down at the bottom, you can see that DFT wire was introduced into the mid-80s, and then it was enhanced when we started leveraging 35 NLT in the early 2000s. And then finally, in 2019, we introduced the process, a new process for how we prepare the DFT wire, which further enhances its strength and fatigue life and overall performance in the applications. So that kind of wraps up the section for high performance alloys and DFT. I'm going to pass the baton over to Brian, and he's going to connect with you regarding strands and cables.
Thanks, Matt. I appreciate that. Again, my name is Brian Woodbury, and I get to speak with you for the next few minutes on our strands and cables product line. But first, before we get started into that, I want to talk about a little bit of terminology just to make sure that we're all on the same page. So when we talk strands and cables, you might be wondering, well, what's a strand? Well, a strand is formed by wrapping individual filers or filaments, or what we would call a wire, together. So strands are typically in a 1x configuration. So as an example, a 1x7, which would be 6 wires wrapped around a core wire, or a 1x19 are popular stranding options. When we take several strands and wrap them together, this produces a cable. Cables could be a 7x7, which is a cable of 7 1x7 strands, or maybe it's a 7x19, which would be 7 1x19 strands. Regardless, Fort Wayne Metals can produce the most complex cable that we can do is a 37x37 construction. And in that 37x37 construction, there would be 1,369 individual filers or wires inside that cable OD. The outside diameter can be as small as a 002 or as large as 0.1875 inches. We've also successfully stranded as small as 0005. And really the trick of stranding and cabling is finding the correct balance of flexibility, brake load, and torque for your particular application. When we talk about common materials, this list basically matches what we say here at Fort Wayne Metals, that if we can draw it, we can strand it. And as you can see, there's a list of stainless steels, cobalt chrome alloys, DFTs, and other high-performance alloys that Matt just alluded to. All of those alloys are able to be stranded or cabled in our facility. Now with this slide, one thing I wanted to highlight was, as you can see on the left, the graphic there that demonstrates as wire count increases, flexibility also increases. However, brake strength has an inverse relationship. Brake strength will reduce as the filer count increases when you compare similar items of the same OD. The chart on the right shows a more detailed view of very common strand and cable constructions. It allows you to compare the relative strengths on the left and the number of filers on the right of the chart. So that way you get an idea of, as you can compare the different constructions to each other. This chart is actually out of a brochure that exists on our website. So if you go to our technical literature and search for the Strands and Cables configure brochure, you can get this chart as well as a lot of other detail related to strands and cables. One additional technique we can provide to the customer to get that perfect combination of brake load to flexibility is a compacted strand, or sometimes you might hear it referred to as a swage. This technique takes the strand through a secondary process to rotary swage the exterior. This compacts the filers against each other. This removes some of that internal interstitial space, stiffening the construction. It also creates a smoother exterior throughout the length of the spool. Fort Wayne Metals may recommend this process to increase brake load or decrease flexibility in the same OD. It can be used to increase the sliding factor of the item as well. And then, as noted there on the right, the percentage of compaction is really dependent on the construction. But if you think this could be helpful in your application, get a hold of us and our Strands and Cables engineers, and let's have a conversation. One last thing I wanted to know, as far as Strands and Cables goes, we do have a configuration tool on our FWM Metals website. This is a great way for engineers and designers to get started by simply selecting 3 parameters by providing the material you're looking for, the min brake load, and the max OD. The calculation will provide constructions that meet those parameters, as well as provide a max brake load at that selected OD. If you aren't finding what you're needing, or you need a solution that maybe is on the fringe of what the calculator is saying is possible, please connect with us and we can discuss other possibilities. Now that we've discussed a bit of the technical details behind strands and cables, I wanted to highlight where you might find Fort Wayne Metals strands and cables used. They are often used in orthopedic applications like securing ligaments or bones. We see them in minimally invasive instruments or used as guide wires, stylets, or endoscopic devices. They are also heavily used as heart pacing or nerve stimulation leads. This list is just a partial list, but gives you a sampling of the many applications that we're used in. And now, as we shift to a close cousin to the strand, is another product that we're going to highlight today. And with that, I'll turn it over to Connor Bates to cover our HHS product line.
All right. So looking at HHS Tube, my favorite product line here. So as Brian said, my name is Connor Bates. I'm the product manager of HHS. So of course it has to be my favorite product line here at Fort Wayne Metals. So The first slide here, I just wanted to show an example of the way that Foreign Metals supports its customers. So at Foreign Metals, we have a dedicated team focused on each specific product line. This is the team specifically for the HHS2 product line. As this goes for most of our product lines, we have product development engineers. They will handle the design and prototyping. We've got process engineers who optimize efficiency. They improve productivity and throughput. We've also got quality engineers who work to develop and implement quality systems in place to make sure that you're getting the highest quality standards needed for your device. This team of dedicated engineering resources is just one example of how Foreign Metals is supporting customers. So what is HHS tube? Well, HHS tube, it's a flexible, hollow, multi-filer strand. It's very comparable to a torque coil, and it offers several key benefits like you might see with a torque coil. It's flexibility, torque, one-to-one rotation. You have improved tension, elongation, kink resistance, compression resistance. You also have precise pushability, and we can really tailor any of these specific properties to meet the needs of the customer's applications. A lot of our product applications are listed down here below, and this is just a fraction of what we actually support in the devices that are utilizing our HHS tubes each and every day. So for general design elements, like I had mentioned, our tubes can be customized in terms of layer count, wire size, wire shape. That could be round or flat. We could do pitch, material. So changing any one of these properties is really helping fine-tune mechanicals and getting what you need out of HHS. The smallest HHS we can manufacture, ID, is 003 thou, and then OD is 005 thou. So pretty small HHS, and then the largest we can produce is 087 ID and 160 OD. There are times when a design window outside of these general design elements is needed. So please reach out to your sales rep. Please reach out to one of us, and we can look into that construction for you and see if it makes sense for producing here at Foreign Metals. I would like to note that for each pitch direction, we typically supplement a left-hand lay or right-hand lay, depending on where your primary torque direction needs to be. And then we would alternate each layer. So if we were going to start with the left-hand lay, it would then go right-hand lay and then back to the left-hand lay. There has been times when we don't alternate each layer, but it all depends on what the customer needs are. So talking about material type for HHS, most of our HHS is made out of 304 stainless steel for high strength. Some of our customers need better corrosion resistance, and that's going to be achieved using 316 LVM stainless steel. Some customers may need better fatigue life. So then, as Matt had shared previously, we're going to use the 35 NLT alloy for fatigue life for those customers that have high life cycles and need lots of cycles for stress and strain. Nitinol is going to be used for shape set parts primarily. So one option that we have and one capability that we have here at Foreign Metals is to be able to shape set nitinol, and we can shape set HHS. So we have several customers that utilize this capability, and that's something that can be done here at Foreign Metals. There's definitely more alloys we can do with HHS. These are just the basic ones. Really, any of the alloys that we can produce, what we like to say is if we can produce it, we can likely strand it into HHS. So if there's an alloy that you're needing, please let us know and we can look into that. There's two main types of end finishes for HHS, or I guess two main types of cuts for these end finishes, and one of them is a shear cut and the other is an EDM cut. As you can see, our shear cut's going to be the most rough cut here. It's great for cost effectiveness or ideal for customers that don't have critical ends. This is going to be your fastest option, as it is just a rough cut with a larger tolerance range. Our EDM cut was brought in because some of our customers are looking for tighter length tolerances. So to get a flush cut on the HHS and tighter length, you're going to need an EDM cut. This is a high repeatability for these end cuts from part to part, and it's used using a fixture in one of our EDM machines. So this is our two end cuts, and they are typically, the EDM cut is typically supplemented with a weld, And the reason that we do that is due to filer shifting. So a band weld is great. It goes around the outside of the HHS. It's done on our manual or CNC laser welders, and it is typically used to hold filers into place. For dual and triple layer constructions, we have what's called a face weld, which is going to be, as you can see here in the pictures on the right, on the face of the HHS. So single layers can also use face welds, but typically it's used for dual or triple layers to be able to hold any type of layer shift from happening in the HHS. Some of our customers do like having a face weld supplemented to the HHS to make sure that the ends are rounded for ease of assembly. All right, now moving on to additional capabilities. So as Brian mentioned, one thing that we have the capability to do in-house is rotary swage. This is going to be a spool-to-spool process, and just like strands and cables, we can also do it for HHS. So as you can see on the picture on the right, you're basically taking the swage and you're compacting the OD of the product as it goes through this operation. It's going to really flatten out those filers and push them closer together. So this is going to be great for customers that want improved torque response. They want improved compression. They may want to increase stiffness or may just want to close gaps. I will say this process does increase stiffness. So if you're looking for more flexibility, swaging may not be the way to go. The next additional capability I want to highlight here is laser welded assemblies. As you can see, we are very up to date on laser welding hypotubes, fittings. We can do miscellaneous shapes. We can even join multiple HHS tubes together when our customers want two separate ends of the HHS to have different mechanical properties. So maybe you want one end to be stiff and one end to be more flexible. Well, we could actually weld two HHS together to get you both, or the best of both worlds. We do offer welds along the HHS. So that is another capability that we have. All right, and moving on, we're going to look at some coatings that we can do in-house. So we routinely do PTFE and ETFE coated HHS. What we really like to do is coat the filers first and then strand this into HHS. We have done shrink tube coating before. We can do PBAX reflow onto HHS. And there are definitely other options such as nylon coatings or any other coatings that Foreign Metals can offer we can look into for HHS. So customers may be looking for good durability from the coating or good lubricity. And so reach out to the rep and we can figure out which coating option works best for you. The next capability we have is what we call a flat wire HHS tube. So this is a recently launched product from Fort Wayne Metals. It is utilizing our flat wire drawing processes and taking those filers and straining them into HHS. So these are going to be rolled flat wire filers, and the flat wire HHS tube is going to deliver exceptional torque performance at a thin wall. So for customers that the round filers may not be able to meet their requirements due to the wall thickness, flat wire could be a great option for that. It does have increased elongation resistance, and it's got increased torque in one direction over round wire. And then the last additional capability I wanted to kind of highlight here is our cleaning and passivation. So we do have routine cleaning steps through the process of HHS, but there are a couple of additional cleaning processes and passivation that you can add on when you're using Fort Wayne Metals. So we do have a nitric number 5 passivation in-house, and that's going to be per ASTM A967. We also have an ultrasonic cleaner. We use a Steris CIP 100 as the solvent for that. So during the bath, we're going to be using that and then doing a couple of rinsing operations and then a drying operation as well. Lastly, I just wanted to highlight our sample program. So we have over 80 constructions available on hand here at Fort Wayne Metals. So if you're interested in a sample, please reach out. We can typically ship these in 1 to 3 days. We also do have 10 constructions of HHS available on chamfer. We're looking at getting up to 25 by the end of Q2 of next year. So there will be more HHS coming onto chamfer as well. Something I just previously discussed in my slide was the ability to coat HHS tube. Matt Vanderus is going to be talking about our capability at Fort Wayne Metals to be able to coat and laser ablate several other products in-house and why you should utilize this capability that we have.
Thank you, Connor. All right. So with insulative coatings, with coatings in general, we routinely process wire materials, strands, cables, all different forms. There's two broad categories that we kind of speak about our coatings. One umbrella is under dielectric coatings, and the other umbrella is kind of under lubricious coatings. So dielectric simply means a material that can transmit an electrical force without conduction. And so you think of an insulator, it prevents electrical leakage and short circuits. So these coatings are under the dielectric umbrella because they're able to be coated or jacketed over a conductor, and they allow some of the electrical energy to flow along the inside without impeding. However, it doesn't allow that electrical energy to penetrate or to leak through that coating. Under these dielectric coatings, some of the most widely used in the industry are in the extrudable thermoplastics, fluoropolymers type category. They combine a great suite of benefits, including a combination of strength, durability or toughness, and of course, the dielectric performance that's needed in conductors for medical. Some of the leading ones that we see widely used, the most widely used that we see is ETFE, or ethylene tetrafluoroethylene. It's really known for its mechanical strength, abrasion resistance, impact resistance. It's widely used for insulating conductors, supporting CRM and neural leads. PFA, PFA, which is perfluoroalkyloxy, is a higher melting point fluoropolymer. It actually has a higher surface temperature than what ETFE does. So it melts at about 260 C, or it can be within service at 260 C, compared to ETFE, which its upper surface temperature is around 150 C. And it's definitely more lubricious. And that's one of the reasons is that folks may leverage a PFA coating for applications that the conductor may be inserted inside a lumen. It just provides a little bit more ease of pushability due to the lower resistance. FEP, or fluorinated ethylene propylene, it is not used near as much from what we see as ETFE and PFA. However, it is used in some applications where you may want a little bit softer coating or something that's slightly more flexible. FEP has a service temp that's almost right in between ETFE and PFA. It's definitely not as durable as ETFE, and it's not as lubricious as PFA, but it kind of sits right in that middle ground. And again, that's just not something that's as widely used, but it is available. Finally, we do have a extrudable PTFE. Its trade name is called mold flan. PTFE, or polytetrafluoroethylene, is mostly used or known for its lubricity. So it is orders of magnitude more lubricious than ETFE, and it's kind of that gold standard for getting a material that's used where lubricity is one of the primary functions. The nice thing about the mold flan PTFE compared to a sintered or just a true PTFE that's paste extruded is that the extrudable PTFE has some groups on it. We believe that it's like PFA groups. So it allows the material to be extruded over the surface and encapsulate like a strand. It has a surface temperature of around 260 C, so near that of very similar to PFA. with the rubricity, and the dielectric strength is in the same neighborhood. Um, for instance, with ETFE, you can kind of count on about 1500 to 1800 volts per mil. Very similar with PFA. Moldflon is in that same range as well. All of those fluoropolymers can be um, mixed with a colorant that allows various colors to be available for those materials. Folks typically use those in devices to error-proof or to color different conductors to make ease of assembly in the device. Another option that we can do with extrudable coatings is to apply a fluting tip in the die geometry. What that allows is small ribs or lobes to be placed on the inside or the outside of the coating. And that can be used to enhance pushability due to the air pockets that are then present between the coating and whatever tube or part of the device that it is being inserted. What we find with dielectric coatings, of course, is very common applications are within CRM or neuro. Many EP catheters now, are leveraging similar technology in that space. Outside of extrudable coatings under that dielectric umbrella are enamel coatings. And what we find is that the most widely used enamel coating for dielectric performance in med device happens to be polyimide. Polyimide has an extremely high-performing dielectric strength compared to any of the fluoropolymers. In fact, it's roughly 3 to 4 times as strong. You can get, we said that many of the fluoropolymers were around 1500 to 1800 volts per mil. You can get that same dielectric performance at about a third the wall thickness. So roughly a third of a mil, you can get that 1800 to 2000 volt performance out of a polyimide. So that truly enables the device designer to be able to build a construction with good dielectric strength where you need to reduce the size of the conductor to try to conceal the footprint of the device. So within catheters, within certain regions of the body, when you need to downsize and reduce that diameter, polyimide may be something to consider. An enamel coating compared to an extrusion operates very differently. It acts differently on the wire itself. The extrusions just kind of act as a jacket around the construction. However, in contrast, the enamel coatings actually adhere to the surface. So some advantages for an enamel could be if you're going to be coiling a material or you need some abrasion resistance or extremely tough, they adhere directly to the wire. However, if you're needing to insulate a strand or a cable and you want to maintain flexibility, that's where an extrusion would be more appropriate. Some common applications for enamels are diagnostic catheters, conductors, and those, like we said, with where you have limited space. The other umbrella outside of dielectric, like I mentioned, is lubricious. So lubricious coatings, the first one that everybody thinks of is PTFE. The polyfluorotetraethylene is widely known as Teflon. Many of you leverage that within your houses with cookware and such. Well, just like food doesn't stick to Teflon pans, the PTFE allows guide wires and catheters and other wires to more seamlessly flow through, whether it's within the body, the vasculature, or within a device. And so common applications, of course, for PTFE would be guide wires and catheters. We offer the extrudable PTFE in-house at Fort Wayne Metals, but we also partner with converters for a paste extruded or a dip or a spray PTFE that can be applied either reel-to-reel or discrete pieces. And we partner with folks such as Merit Medical for their Duraskin and Lubraskin. A couple other coatings just to briefly mention. Nylons are great for protection, for abrasion resistance. It's a very tough coating. Doesn't give you the dielectric performance or the lubricity, but it's another reason to potentially add an insulation to a strand. You can get different colors. You can get some extra abrasion layer between your strand and whatever pulley or whatever system that it's being rubbed against. One common one that we use is acrylamide, which is a polyamide, not to be confused with polyimide, but that is available in Fort Wayne as an extrusion. And finally, just to touch on PBAX, which is the polyether block amide. It's great flexibility, durability, known for its biocompatibility, and also the ability to be bonded to other layers or other coatings. So many folks use PBAX in catheter applications where you need to bond one layer to another. You may want to coat it with a hydrophilic coating for wet lubricity when it goes into the body. So that's a high-level subsection of the different coatings that we offer. And finally, once you get the coating on the material, many of our customers and device designers want to be able to weld the conductor or join the material with a crimp or a component. And so rather than leveraging a mechanical stripping process that can damage the wire and is a little bit more difficult to control tolerancing, Fort Wayne offers laser ablation that is able to remove the coating with a pretty clean shoulder, as shown in the upper right picture. And it allows us also to do customized zones where we can provide stripped regions within a length of material that will allow the device designers to do various terminations along that conductor. Our lasers are specifically geared towards ETFE, which we find is most widely used in the industry. And we do have partners and conversion partners to be able to ablate other coatings such as PFA or polyimide as necessary. So with that, I'm going to pass it over to Brian to touch on our custom assemblies.
Excellent. Thank you, Matt. I appreciate that. And just a reminder as well, I know we're running up on time here fairly quickly, but if you have a question, please feel free to utilize the Q&A functionality. Even if we don't have a chance to answer the question on the webinar today, we can definitely take note of that and provide you an answer to your question following this webinar if that is so required. So we're almost done. So to close out, I get to dive into what Fort Wayne Metals can do with regards to custom assemblies. So custom assemblies at Fort Wayne Metals is really an engineered to order solution. As the name suggests, we are providing custom solutions to our customers. These items are typically built to your specifications, utilizing Fort Wayne Metals material and processing expertise to help guide your design decisions. We have a team of over 10 new product development staff to work with you to find a solution to meet your design needs. This team of engineers and technicians supports hundreds of new designs annually, ranging from a simple cable with a crimp to very complex multi-component assemblies. We're able to build these to handle small prototype runs of a few, 10 to 15 to 50 or all the way up to very large production volumes. Since a lot of what we do is proprietary and customer specific, I'm not able to provide you with a lot of options or examples of what we do. However, I did want to walk through and spend a few minutes covering some of the capabilities we have from end treatments on our cables and wire. As you can see on the screen there, fused ends is a technique to cut wire cut cables while fusing the filers to prevent fray. This is an inexpensive way to finish and is good at preparing the cable for another step in your assembly process. Next would be a bead. Beads stand proud of the OD of the cable. Typically, beads need to be less than 2x the OD of the cable. Beads are used as an attachment to another assembly component or maybe a mating component inside your device. We also provide a bead and swage. This is a bead like before, however, it's swaged down with some of the techniques we've talked about prior to create a cylindrical area of solid material. This is good for passing down aluminum or also provides a good surface if you or need to conduct a welding next step. As Connor mentioned, we can do square ends as well, so we can produce a nice clean edge. This is a great solution if you have a mating component, and that edge is very critical to the geometry of your device. We can also do coining, as you see near the bottom there. This is a flattening of the wire. This is can be completed at the end or in the middle of the wire, and this is typically used as an attachment point, specifically in overmold applications. We have a plethora of other options as well, additional end treatments like deburr, bullet nose, band welding, etc. If you have any of those thoughts or need help there, please reach out. We would love to point you in the right direction. We also have the ability to produce several fittings as well. Many of those fittings are matched to meet a customer specification. Whether you need a spherical ball to fit into a spherical pocket, allowing for near full cable break strength, or maybe your design requires a cylindrical or a hex fitting to match a mating component, we're here to assist. If your application has specifically very tight dimensional tolerances, maybe the Fort Wayne Metals patented puck technology is the right fit for you. As noted too, we also have a machine shop on site at Fort Wayne Metals to handle your rapid prototype needs. We also have a number of other partners that we can utilize for maybe that longer term high volume production demands. Here at Fort Metals, we are continuing to invest in our assembly segment. As Matt mentioned, we have added to our assembly facility last year. In addition to the square footage, we are continuing to add to our machine capabilities as well. As you can see here, we've acquired or built several machines. These include automation of assembly, grinding, laser welding, or upgrading from standard pneumatic to servo-controlled presses for better precision and repeatability. So as we wrap up, I wanted to let you know that you'll receive an email follow-up following this webinar. In that email, you'll receive a link. I would encourage you to utilize that link if you have any questions or have a project, as it will connect you with your Fort Wayne Metals sales rep. And we would love to have a conversation about what you're working on and how Fort Wayne Metals can help you in that next new project. So as I wrap up, I'm going to turn it back over to Connor to answer any questions that may have appeared.
All right, so we do have a couple of questions here in the Q&A section. And as a reminder, that Q&A button's at the top. So if you have any questions popping up as we're closing out here, feel free to click on that Q&A button and go ahead and write up your question. So one of the questions we have here is, what testing do we have available in-house to confirm passivation effectiveness? And we do have several options. One of our most common options is a copper sulfate test for that ASTM. I also believe we have a free iron test as well, and a salt test to confirm passivation effectiveness. I will go on to say that Fort Wayne Metals has a materials testing lab. So we utilize this lab for much of our testing, whether it's torsional stiffness, break load, it could be passivation. So please reach out to us and we can use that lab for testing. All right, one of the other questions here, I believe this is going to be for you, Matt, for coated and ablated. It says, since you have the capability to apply several different coating technologies, are you able to combine them to take advantage of various properties?
Good question. So we talked about some of the floor polymers. We talked about enamels. Absolutely, there are different situations where we have needed to improve, let's say, the dielectric performance in a application that undergoes heat and compression. So we've leveraged polyimide as the first layer on the material, which has a very high heat resistance, extremely durable to compression. And then we've overjacketed that with one of the fluoropolymers, in that case, PFA, because of its temperature. But we could then leverage the color, and it provided an extra layer where there was a twisted pair conductor that was undergoing some pressure. We've also leveraged ETFE and PFA in similar systems where we'll coat like 1x7 conductors with PFA. and then we strand those into a multi-filer coil, and then we can overjacket that with an ETFE. As you recall, ETFE has a lower processing point, so we're able to overjacket a group of conductors with ETFE. So those are a couple examples. Obviously, many other options and reasons. Just encourage you guys to reach out to our team. Good question.
All right, moving on to the next question here. It says, what are your capabilities for rapid prototyping or small batch production? And I can go ahead and handle this one. So Fort Meadows has what's called the Velocity program, and this is basically an expedite through our facilities. So if a quote comes in, when it's asking for a velocity option, we're going to quote it with velocity, and it's going to be just a little extra charge for the ability to be able to move it to the front of the line once it gets to the next operation. So it's definitely something teams should take advantage of. I will say for small prototype runs, maybe it makes sense to ask for a sample. So most of our product lines have samples readily available. So reach out to your rep and see if we have a sample within your design window available for what you're looking for. We are constantly trying to improve our rapid prototyping areas. So please be on the lookout for any improvements that we're making here in the next couple of months moving forward. All right, and last question here, it looks like. So Brian, I think this is going to be for you for your mechanical assembly. It says, what options do you have for automation or robotic assembly processes to speed throughput?
Hey, Connor. So yes, thanks for that question. And yeah, we have a couple different options. Again, like I mentioned, we are continually investing in automation. We did recently, and it's in the final stages of validation, a new machine to help with basically automating the insertion and crimping of crimps on a cable. So that will be in full production here very soon. So definitely for those high volume applications where you have a cable with a crimp, either distal or medial, we can definitely take care of those in high volume to reduce that cost. And we also utilize, for those that are familiar with collaborative robots, or sometimes called cobots, we have a one cobot cell that does some what we'll call semi-automated assembly. So requires the operator to load different components, and then the cobot will take care of joining, testing, visually comparing those assemblies to ensure compliance to the customer specification. So definitely have some machines, and depending on your application, if one of those doesn't quite work, depending on the volume, we can definitely work with you to automate your design as well, to get you at a price point you need to meet your demands.
Great, thanks, Brian. All right, well, that's going to conclude our Q&A session. Matt, I'm going to hand it back over to you to conclude us here for this webinar.
Absolutely. And I just want to say thank you to the folks that have joined us today. Appreciate you taking an hour to spend to hear about how we may be able to partner with you to support your next device design. For those of you that may be able to join the next session, just a teaser out there, an upcoming session for our webinar will be with our R&D team. So stay tuned for some potential emails hitting your inbox with the ability to join up to connect with our R&D team. So thank you again, and hope you guys have a great day.